Long time no see. Glad to be back in the Coppell office for a while and have a chance to actually be on the company meetings. So this week Marcia asked me to throw together a topic on Fast Track Data Warehouse. That's why I call it Not Your Grandmother's Data Warehouse. A lot has really changed beginning with SQL Server 2008 and how Microsoft looks at the BI stack. So what they did is they got together, I think it was with, I don't even remember the vendor, and they came up with a goal of how to optimize everything so that data warehouse would be fast and you could retrieve data. So today's discussion, what is Fast Track and how can SE embrace it? How SE can embrace it is going to be fairly straightforward. We can do Fast Track assessments, POCs, implementations, and sizing. More importantly is learning what Fast Track is so that we can dive into those assessments. A lot of the slides you're going to see today actually come from Microsoft, either some of their marketing materials or training that myself and Andy actually have attended. So in short, what is Fast Track Data Warehouse? Well, it's a reference architecture. It's not the appliance that PDW is. What Microsoft did was they got together with HP and Dell and several other hardware vendors and said, let's look at what's going on with data warehouses. What they found out is that a lot of data warehouses have large scan type queries. They're reading pages and pages of data because they're doing summary data, they're doing aggregations. They're reading data across multiple years and trying to get, averages. They do a lot of hash joins, and they're in the 4 terabyte range. So they started looking at what can we do to optimize this workload. Once they came up with that, they said, okay, well, we've got some reference architectures for small data warehouses, medium data warehouses, and large data warehouses. Typically, they're based on size. 4 terabyte data warehouses being on the smaller side with 48 terabytes being on the larger. But that said, they can also be characterized into workloads. Then what they did was they said, okay, well, let's leverage all aspects of the database spectrum, the server processor, HBA, fiber switch, and the storage, and come up with a day to move this data from the storage into memory as fast as possible. So how does it work? Well, again, it's predicated on scan-centric workloads. They want you to load as much data in contiguous blocks on the disk as possible. Don't do any fragmentation. We want to try to read as many extents in a row as possible. Now we're going to leverage SQL Server's read-ahead capability. We're going to leverage the scans prefetch capability. So this is why I say this is not your grandmother's data warehouse. In this situation, scans are good. Seeks are bad. Seeks are through your OLTP databases. Unlike other data warehouses, indexes are bad. Why? Because they can lead to fragmentation, which screws up the contiguous data, and the extents can lead to interleaved extents. And so then we're wasting our disk reads. What's also backwards from most data warehouses is we try to use as few disks as possible. Right now, a lot of data warehouse implementations are built around large SAN or storage fabrics that have multi-terabytes of data. Well, Fast Track says, no, let's do as few disks as possible, lay the data out in continuous blocks, and just read, read, read. So traditionally, we would go out to a client and we would look at IOPS. No more. It's all about throughput. How fast can I get data off the disk and into the memory and the processor? So when we'd normally scale out or spec out a storage system, we'd look in the IOPS, 1,500 IOPS, 2,000 IOPS. Right now, we're talking about, no, we want to get 1.5 gigabits per second throughput, or 1.5 gigabytes per second of throughput. So the way Microsoft specs out the reference architecture, so they have small, medium, and large. They would consider a small data warehouse typically in the 4 to 12 terabytes range, and the reference architecture that would fit it would be a 2-processor model, something like a the E5-2690 that Larry and I were just talking about, a 2x6, 96 gig of RAM. Medium data warehouse workload will be 12 to 24 terabytes with a 4-processor architecture and 128 gig of RAM. And then we have our large-scale data warehouses, 24 to 48 terabytes, 8 processor architectures, and 256 gigabytes of RAM. There's an actual sizing spreadsheet we'll get to later, but in general it's all about the size of the data. And again, one thing I forgot to mention, when we're talking about size of data warehouses, when we say 4 to 12 terabytes for small, that's compressed data. So we're talking 4 to 12 terabytes compressed. So this is Microsoft's Fast Track Memory Sizing Guide, 2-socket server, 96 gig up to 256 gig. This is all based on the Fast Track 3.0 best practices. So how does Fast Track work? Raj has asked the question, using SQL compression or Windows disk compression? Raj, the answer is SQL compression. So we're going to kind of get a deep dive here about how does Fast Track really work. And remember we talked about balancing workloads, in other words, i.e. through contiguous extent allocation. So as we show in this diagram here, we've got our pages for table X laid out in extents 1 through 128. Well, at max, SQL Server can read up to 512K reads. If you can look at how SQL Server reads memory, we have 8 pages per extent times 8K pages at 64K and 8 extents, or 512 KB. So that's what SQL Server is going to read. We have 2 megabytes free prefetch on the SAN. Let me say that 3 times fast. So SQL Server is going to read 512K. We're going to prefetch another 2 meg from the SAN, so we're already into extents 20 if our data is laid out in contiguous blocks on the disk. So we get one large continuous read. So now we're going to combine that with SQL read ahead, and we're going to queue our pending read requests at the storage enclosure level. So this is where people like Chris come in handy. You know, we want to maintain that queue depth. We want to keep that storage system busy, but not overloaded, but not idle either. Why? Because the read-ahead efficiency maintains the concurrency, so we can keep parallel threads. Let me jump back a slide here. If I've got multiple threads going, each of these threads can read in parallel up to 4 meg or 8 meg. So I can balance my workload. I can get large parallel reads coming off my storage system. I forgot my title on this and what this slide is about. Oh, this is about the 8 meg read ahead per thread. So again, I've got my 512K SQL read. I've got my 2 meg prefetch. And then for each thread, I've got 8 meg read ahead on the SAN. So now I can almost read 128 extents of data. So now think about your data warehouses. We've got these large fact tables that contain 5, 7, 10 years worth of data. And I've got some business analyst or exec that wants to come up with an average sales for the last 10 years. What is he doing? They're reading from that fact table. They're doing averages and sums. So I want to read all the data stored in this fact table through all these extents. Larry has a question. So Larry's question is that is assuming there is no fragmentation, whether it's index fragmentation or NTFS file fragmentation, and that is correct. That goes back to the first slides there. Indexing is bad. Why? Because it introduces fragmentation. We'll get into this later with our load strategies. The load strategy also helps to keep that data in contiguous blocks so that when we... Question from Sharon, RAID 5 as well. The fast track recommendation, Sharon, is to use RAID 10. But remember, it's also fewer disks, not more disks. So we'll get this later in the fast track sizing guide, but for the most part, once we do the assessment, and when SE comes up with the Fast Track Data Warehouse sizing calculator, we say you have a small data warehouse or you have a medium data warehouse. Part of the sizing calculator also shows what type of throughput you need and how much storage you need. We hand that off to the vendor. Typically, we've done this with HP, and we say, hey, client A needs a 12 terabyte data warehouse with 1.8 gigabytes per second throughput. And HP comes back and says, okay, here's your storage allocation. Here is your number of HBA cards. But remember, they are the partner with Microsoft on Fast Track Data Warehouse. They know how to size the SAN for the data warehouse size. In fact, I can even show you, let me switch to this real quick. This will take a second. People in the Coppell office can see this. As soon as I get this loaded, I will share it on my screen. So this is an actual sizing quote from HP based on what we recommended to the client. And this is a balanced storage configuration for a 12 terabyte Fast Track data warehouse. We specify the throughput requirements. We specify the data size. HP came back and says, this is the storage that will fit your 2-processor model to give you a balanced workload. The question from Larry is, the Fast Track ratio of LUNs to core, does that include hyper-threading? And I can't remember off the top of my head, but I know for most data warehouses they say turn hyper-threading on. All right, so why all the fuss about aligning storage? What is the key attribute about Fast Track? Well, it's balanced workloads again, and scan-centric workloads. So if my storage is aligned and my data is aligned, then I can get fast I/O from my disk. So how do we get this aligned storage and balanced workloads? It's all about database and table design. Larry, does that one look nice? And architecture. So how do we achieve that? Through contiguous blocks on disk, meaning sequential loads of data. Larry, going back to your previous question, indexing is bad. Indexes can cause fragmentation. We want to use uniform extents, so we're going to set trace flags 1117, 610, and 834. We're going to build out our database such that all the files are pre-built across all our LUNs, and then we're going to start a load. And I see a question from Justin coming up. The question is, does this require no changes to historical data? Can you elaborate more on that, Justin? If you want, you can take your phone off mute and just ask the question. Okay, so you're talking about updates to data once it gets into the data warehouse.
Yes.
Okay, well, ideally, we're not going to make updates to the keys that are in the data warehouse. We're going to update maybe some fact element. I'll get to James's question next. I'm still answering Justin's. So yes, there are going to be changes to historical data. There are actually going to be incremental changes to data. And so there are two Fast Track loading methodologies. There's the historical load, or the one-time load, where we get all the data laid out sequentially. And then we have our daily incremental loads. Ideally, we're going to load new records first so that we keep appending to the end of the table, and then update individual elements as needed. Those updates, though, typically do not involve updates to the keys. So we'll get into the loading methods next, but ideally, Justin, we don't want to rearrange the keys. Does that answer your question? Okay, now to James Johnson, I would make the assumption that this should be a read-only database. You can make it a read-only database, but remember you're going to have incremental loads. You're going to have daily loads, so you could make it read-only, but you're going to overwrite it the next day or make updates. What you can do is then snapshot off that. Okay. There's actually another trace like I believe it's 1118, but they all work together for uniform extents and scan-centric loads.
Doug,
yes.
One other question about the incremental updates, and is it not possible to track historical changes using Fast Track?
You're talking about type 2 changes?
Yes.
It is possible. Marsha only gave me 30 minutes for this presentation, so we don't go in.
Aw, don't throw her under the bus.
You can go over your 30-minute allotment if you like, Doug.
I can go, but unfortunately I only prepared about 30 minutes worth of content. So that will be another Fast Track presentation on loading methodologies. You should put me on the schedule, Marsha, on Fast Track loading methodologies. Who was that asked the question, though, regarding type 2? Was that James or Justin?
That was me, Justin.
Okay, Justin. We had a lot of problems with incremental loads and type 2 changes at Ernst & Young. They can be dealt with, and avoiding fragmentation. So this is how a typical file layout would look like in Fast Track. We've got our LUNs spread out for our data. We're going to stripe it across all 16 LUNs. Our first database here, we've got our data warehouse database. We have our staging database, and then we have our TIMPDB on separate LUNs, and then we have our logs. So we're going to build the file out sequentially across all 16 LUNs. We're going to build our staging database across all 16 LUNs. And again, staging database could be on a separate server. It could be on the same physical server. But the primary goal is this data warehouse database at the top is laid out sequentially across all the LUNs. This is what we did at Ernst & Young. They said, here are 12 500 gigabyte drives. We built out 12 500 gigabyte data files. We built them out empty, and then we started loading them, one table at a time. So each table gets loaded sequentially. So some of the load strategies, and again, that's why I say Marsha originally told me I had 30 minutes for this, and I could spend a whole hour just on load strategies. But off the top of my head, some load strategies. We load a stage table that has a clustered index. Why? Well, because that puts the data in order. Once the data is in order, then I can load from my staging database into my target database and keep that data sequential. We say avoid parallelism here. That's really for the final data warehouse load. Why? Because if I've got multiple threads loading the data warehouse, my ordering is not guaranteed. So we want to do things like option max stop 1 as we're loading the data warehouse. So here's an example load strategy. We've got flat files coming into the staging database. We've got our source database coming into the staging database. I can do parallel loads of my flat files, or I can do parallel loads here from my source database. Get it into the staging database into a clustered index table. The data there is ordered. And then from that ordered staging table, then I load my target database. That keeps the database, or in all the files, contiguous and avoids fragmentation. So that's kind of an overview of Fast Track. So what can SE do? Well, we can do Fast Track assessments. Number one, does the client workload even meet Fast Track workload requirements? If they do, what size do they need? They need small, medium, or large. So we can do the reference architecture recommendations and the Fast Track sizing. We can actually do the Fast Track implementation, help them order the hardware, build out the servers, and ETL design so that they maintain that contiguous blocks of memory or contiguous blocks on the disk so that they avoid fragmentation and they can meet those scan-centric workloads. So the fast track assessment, similar to a scalability assessment, do we have scan-centric workloads? We go in there, we assess their workload, we run some queries, and I'll give a demo of that right now. What we're looking for is, do you meet fast track? So let me switch over to Management Studio, and I'll show you some queries that I've used in the past. All right, so the first one, and I know Larry's used this one quite a bit, is IO virtual file stats. So what I'm looking at here are the number of bytes read on my target database. I want to find databases that have large bytes read. So you see here I've got it calculated out here of megabytes read. I want to see gigabytes read. I don't want to see megabytes being read. I want to see gigabytes being read from the disk. Well, just because I have gigabytes being read from the disk doesn't necessarily mean it's scan-centric, but that means that, hey, this FAMC database is a potential candidate because, hey, it's got, 26 gig of reads. So then what I come back to is I look at the exec sessions and exec requests queries. Actually, it's this one over here. What I'm looking for here are, again, high logical reads and high physical reads. This is where it's going to tell me I do have scan-centric workloads, and I actually get the query that says, hey, this is what's going on in your system. I actually have a version of this that I will run at the client that about every 30 seconds for a period of an hour or two to capture the workloads and see every 30 seconds what's hitting your system. And I can find those, quote, scan-centric workloads. And once I find those, I can say, aha, fast track will benefit you. If I don't see a lot, I will be honest with the client and I maybe step on Microsoft's toes that, hey, right now I'm not seeing a workload that's going to benefit from fast track. Maybe we should go another route like optimization. Now, I've shared these queries with Andy and the BI team. So once we go through that, I'll close this. I'll load up another spreadsheet here. Okay, so this is Microsoft's Fast Track Sizing spreadsheet. There is a number called the MCR. It is a measured consumption rate. It is a synthetic number that says how fast can your processors consume data. And there's a sample query that they use with the AdventureWorks database. The goal is to find a table that's large enough that I can read it all into memory without incurring any disk I/O. Once I can do that, I want to run some sort of aggregation query on it and find out how fast it returns that data. And that gives me an MCR. So then we plug in the number of concurrent sessions, the capacity requirement, and it gives us all these numbers that we need to go to HP or to Dell and say, we need two processor, a 2 proc box, or we need a 4 proc box. So right here, this would be if we were in a 4 proc box, we'd need a 4x8. If we were in 8, we'd need an 8x4. So this particular one, we need a total of 32 CPUs. And we need an aggregate throughput of 80,000 megabytes per second. So then we pass that off to HP or Microsoft and say, can you provide us the storage specifications? And that's where that other spreadsheet came from. That was what HP gave us back after we said, hey, this is what the client needs. A lot of this documentation is out on Microsoft's website if you look up Fast Track 3.0. I'm not sure if Andy has stored this out on the BI portal, but if not, I will also as well. I just talked about the MCR and the Fast Track Sizing worksheet, which should bring me to Q&A right at Marcia's 30 minutes. Any questions from everybody?
This is James Johnson. I've got a question on what forms of or type of hard drives are being recommended? Would it benefit from solid state or just a large 15K SCSI?
They are physical hard drives. They are not SSDs at this point. Typically, they are the faster 15K iSCSI disks.
And I'm assuming that they would be preference to be laid out in a 5-0 type of array, or just a standard 5, or not even RAID controlled.
RAID 10, and there's actually it's 1 LUN per core as the recommendation from Fast Track in Microsoft.
Okay, gotcha.